A well point is a device used to collect groundwater from an aquifer. It is installed at the bottom of a well and has a screen that allows water to enter the well while keeping out sediment. Well points are often used in conjunction with a submersible pump to pump water from the well. Let's delve into the specifics of well points, their construction, how they function, and their applications in water well systems. The primary function of a well point is to efficiently draw groundwater from the surrounding aquifer into the well. This is achieved through a carefully designed screen that filters out sand, silt, and other particulate matter, ensuring that only relatively clean water enters the well. The construction of a well point typically involves a cylindrical body, often made of stainless steel, PVC, or other corrosion-resistant materials. At the bottom of the cylinder is the screen section. This screen is the critical component that allows water to enter while excluding sediment. The screen's design is crucial, balancing the need for adequate water flow with the requirements to prevent sediment from entering the well. Screen openings, also known as slot sizes, are carefully selected based on the particle size distribution of the aquifer material. If the slot sizes are too large, sediment will enter the well, leading to pump damage and reduced well efficiency. If the slot sizes are too small, the well's yield will be restricted. Different types of well point screens exist, including wire-wrapped screens, slotted screens, and mesh screens. Wire-wrapped screens are constructed by wrapping a continuous length of wire around a series of vertical rods, creating precise and uniform openings. Slotted screens have machine slots cut into the cylinder wall. Mesh screens consist of a woven mesh material bonded to a supporting frame. The selection of screen type depends on factors such as the aquifer material, water chemistry, and the desired well yield. The installation process for a well point typically involves driving or jetting the well point into the ground to the desired depth. Driving involves using a hammer or power driver to force the well point into the soil. Jetting uses high-pressure water to create a slurry that allows the well point to sink into the ground. The method chosen depends on the soil conditions and the available equipment. Once the well point is installed, it is connected to a submersible pump. The submersible pump is placed inside the well and is used to lift the water to the surface. The pump is typically powered by an electric motor and is designed to operate submerged in water. The size and capacity of the submersible pump are selected based on the well's yield and the required water pressure and flow rate. Well points are commonly used in situations where the water table is relatively shallow and the aquifer is composed of unconsolidated materials such as sand and gravel. They are often used for domestic water supply, irrigation, and dewatering applications. In domestic water supply systems, a well point can provide a reliable source of water for household use. In irrigation systems, well points can supply water for crops and landscaping. In dewatering applications, well points can be used to lower the water table in construction sites or other areas where excess water is a problem. The performance of a well point can be affected by several factors, including the aquifer's properties, the well's design, and the installation method. The aquifer's permeability, which is a measure of its ability to transmit water, is a key factor. An aquifer with high permeability will yield more water than an aquifer with low permeability. The well's design, including the screen size and the diameter of the well point, also affects its performance. A larger screen size will allow more water to enter the well, but it may also allow more sediment to enter. A larger diameter well point will have a larger surface area for water to enter, but it will also be more difficult to install. The installation method can also affect the well point's performance. If the well point is not properly installed, it may not be able to draw water effectively. For example, if the well point is driven into the ground too forcefully, it may damage the screen. It's important to understand some potential problems that can occur with well points. Firstly, clogging can occur when the screen becomes blocked with sediment or mineral deposits. This reduces the flow of water into the well and can eventually render the well point useless. Regular maintenance, such as backwashing or surging the well, can help to prevent clogging. Secondly, corrosion can damage a well point, especially if it is made of a material that is not resistant to the water's chemistry. Corrosion can weaken the well point and eventually cause it to fail. Selecting a corrosion-resistant material for the well point can help to prevent this problem. Thirdly, well points can be damaged by physical impacts. For example, if a well point is struck by a rock or other object during installation, it can be damaged. Care should be taken to protect the well point from physical damage. When selecting a well point, consider the following factors. Firstly, the aquifer's properties are important. The well point should be designed to work effectively in the specific aquifer conditions. Consider the particle size distribution of the aquifer material and select a screen size that will prevent sediment from entering the well. Secondly, consider the desired well yield. The well point should be sized to provide the required amount of water. A larger diameter well point will typically provide a higher yield. Thirdly, consider the water chemistry. The well point should be made of a material that is resistant to the water's chemistry. If the water is corrosive, select a corrosion-resistant material such as stainless steel or PVC. Fourthly, consider the installation method. The well point should be designed to be installed using the available equipment and techniques. If the soil conditions are difficult, select a well point that is designed for those conditions. In summary, well points are important components of water well systems. They provide a means of collecting groundwater from an aquifer and delivering it to the surface. Understanding the design, function, installation, and maintenance of well points is essential for ensuring a reliable and sustainable water supply. When dealing with submersible pumps in conjunction with well points, several electrical considerations come into play. Firstly, voltage requirements are critical. Submersible pumps typically operate on either 120 volts or 240 volts alternating current. The voltage rating of the pump must match the available power supply. Secondly, amperage draw must be considered. The pump's amperage draw determines the size of the circuit breaker and wiring required to supply power to the pump. Refer to the pump's nameplate for its rated amperage. Thirdly, wiring size must be adequate. The wiring that supplies power to the pump must be sized appropriately to handle the amperage draw and prevent voltage drop. Voltage drop occurs when the voltage at the pump is lower than the voltage at the power source. Excessive voltage drop can damage the pump motor. The National Electrical Code (NEC) provides guidelines for determining the appropriate wiring size based on the amperage draw and the length of the wire run. NEC Table 310.15b16 is commonly used for this purpose. Fourthly, grounding is essential for safety. The pump and all associated electrical equipment must be properly grounded to prevent electrical shock hazards. A ground wire should be connected from the pump to a grounding electrode, such as a ground rod or a metal water pipe. Fifthly, overcurrent protection is required. A circuit breaker or fuse must be installed to protect the pump motor from overloads and short circuits. The overcurrent protection device should be sized appropriately for the pump's amperage draw. Sixthly, a disconnect switch is recommended. A disconnect switch should be installed near the pump to allow for safe disconnection of power for maintenance or repairs. The disconnect switch should be readily accessible and clearly labeled. Seventhly, submersible pump cable must be used. The cable that connects the pump to the power supply must be specifically designed for submersible pump applications. This type of cable is typically waterproof and resistant to chemicals and abrasion. Eighthly, proper wire connections are crucial. All wire connections must be made using waterproof connectors or splices to prevent water from entering the electrical system. Water can cause corrosion and electrical shorts, leading to pump failure or electrical hazards. Ninthly, variable frequency drives or VFD can improve efficiency. VFD can be used to control the speed of the pump motor, allowing for variable flow rates and reduced energy consumption. VFD can also provide soft starting capabilities, which can reduce stress on the pump motor and extend its lifespan. Tenthly, regular inspections are important. The electrical system should be inspected regularly for signs of damage or deterioration. Check for loose connections, frayed wires, and corroded components. Addressing these issues promptly can prevent more serious problems from developing. When working with electrical systems, it is crucial to follow all applicable safety codes and regulations. If you are not qualified to perform electrical work, consult a licensed electrician. In addition to these electrical considerations, it is also important to consider the hydraulic performance of the well point and submersible pump system. Firstly, well yield is critical. The pump should be sized to match the well's yield. If the pump is too large, it can draw down the water level in the well too quickly, leading to pump cavitation or dry running. Secondly, total dynamic head, or TDH, must be calculated. The TDH is the total pressure that the pump must overcome to deliver water to the desired location. It includes the static head, friction losses in the piping, and any pressure required at the discharge point. Thirdly, pump curves must be reviewed. Pump manufacturers provide pump curves that show the pump's performance at different flow rates and TDH values. These curves can be used to select a pump that will operate efficiently and reliably in the specific application. Fourthly, pipe sizing is important. The piping that connects the pump to the discharge point must be sized appropriately to minimize friction losses. Too small of a pipe can significantly reduce the pump's performance. Fifthly, check valves are needed. A check valve should be installed in the discharge line to prevent backflow of water into the well when the pump is not running. Backflow can contaminate the well and damage the pump. Sixthly, pressure tanks are helpful. A pressure tank can be used to store water under pressure, providing a more consistent water supply and reducing the number of pump starts and stops. Seventhly, flow control valves provide benefit. Flow control valves can be used to regulate the flow of water from the well, preventing overpumping and protecting the aquifer. Eighthly, water quality is important. The water from the well should be tested regularly to ensure that it meets applicable water quality standards. If the water is contaminated, it may need to be treated before it can be used. Ninthly, well maintenance is essential. The well should be inspected regularly for signs of damage or deterioration. The well should also be cleaned periodically to remove sediment and mineral deposits. Tenthly, record keeping is important. Maintain records of well construction, pump installation, maintenance, and water quality testing. These records can be helpful in troubleshooting problems and managing the well over its lifespan. The depth of the well and the type of soil can influence the choice of well point and pump. In deeper wells, a more robust well point may be required to withstand the higher pressures. In sandy soils, a finer screen may be necessary to prevent sand from entering the well. The surrounding environment also needs consideration. If the well is located near a potential source of contamination, such as a septic tank or a landfill, extra precautions should be taken to protect the water quality. This may include installing a well seal to prevent surface water from entering the well or using a more sophisticated filtration system. Also, local regulations need to be observed. Water well construction and operation are typically regulated by local or state governments. Be sure to comply with all applicable regulations. The regulations may cover aspects such as well location, construction methods, water quality testing, and well abandonment procedures. In summary, selecting and maintaining a well point and submersible pump system requires careful consideration of numerous factors, including electrical requirements, hydraulic performance, well characteristics, environmental conditions, and regulatory requirements. By addressing these factors, you can ensure a reliable and sustainable water supply for your needs.